Hi class, this is Mrs. Snowback. Today we're going to do Unit 5, Lesson 4, and we're going to start with the triangle proportionality theorem. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional length. Let's jump down to example 1 and I'll show you what I mean. So in example 1, you can see that we have two triangles, a smaller triangle and a bigger triangle, and they overlap each other. And the bottom sides are parallel. So what that means is the other two legs will be proportional. So we set up a proportion like 20 over x will equal 18 over 9. And again, since these two sides are parallel, that's why we can set up the proportion. Cross multiply. So we get 18x equals 9 times 20. 18x equals 180. Divide by 18, x equals 10. And it kind of makes sense now that you see it. 9 is half of 18, so 10 is half of 20. The midsegment of a triangle. So we've talked about midsegments of trapezoid. Well, the midsegment of a triangle works the same way. If I find the middle of one side of a triangle, so like that point right there is in the middle, and this point over here is in the middle of this side, if I connect those, that is a midsegment. So that is a midsegment. Now, technically, each triangle will have 3 midsegments because I could also find the middle of this side down here and connect it. That would be a midsegment, or going this way, that would also be a midsegment. So every triangle will actually have 3 midsegments. So now that you know what a midsegment is, here's the triangle midsegment theorem. A midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 of the length of that side. So in other words, if I have a triangle and I find the middle of one side and the middle of another side and I connect them, that's the midsegment, and that midsegment is parallel to one of the sides. And also, it's half the length. So if this down here is 10, this midsegment would be 5, for instance. So go to example 2. JH, segment JH, is the midsegment of the triangle. Find x. Well, this is 9. It should be parallel to this, which is going to be the length of x. And so 9 times 2 is 18. This would be 18. The midsegment is half of the side it's parallel to. Proportional parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, then they cut the transversals proportionally. So take a look at this picture over here. Let's say that these 3 lines are all parallel. And let's say the distance right here is 10, and let's say the distance over here is 30, and let's say the distance over here is 24, and let's say we don't know this distance. Now, obviously, it's not drawn to scale, but that's okay. If those 3 lines are parallel, the little segments in between them on the transversals will be proportional. So you could do like 10 over x equals 30 over 24, and they would be proportional to each other, and you could cross multiply to solve it. So you would do the 30 times the x and the 10 times the 24. So you'd get 30x equals 240, and you'd divide by 30, and you would get x equals 8. So pretty cool if those lines are parallel. Okay, next thing, congruent parts of parallel lines. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So let's say these are parallel, and let's say this is congruent to this. Then this one has to also be congruent to this one, because whatever happens on one of the transversals, the other one is going to be proportional. So let's say this is 4 and 4, and this is 3 and x. Well, x would have to be 3. because they would have to be both congruent. If the one on the right is congruent, the one on the left, the segments would have to also be congruent. Example 3. In the diagram, K Street and Bay Street are parallel. Okay, so everybody find K Street and Bay Street. So those are parallel to each other. And then the question says, find X. Well, what we have here is we have a triangle. And in this triangle, we have two parallel sides, which means the segments that it's cut into are proportional. So the 1 over 0.8 is equal to the 1.4 over x. 1 over 0.8 is equal to 1.4 over x. And you can set up a proportion. You can cross multiply. 1 times x is x. And then you have to do 0.8 times 1.4. And when you multiply 0.8 times 1.4, you get 1.12. And you should label it. Looks like our picture is labeled in kilometers. So this part right here would be 1.12 kilometers. All right, let's try number 4. Now, in this picture, I can see 3 parallel lines, which means the transversals are going to be cut proportionally. But over on the right, on this transversal, I see 2 tick marks, which means those 2 sections are congruent. So the 2/3 y plus 3 will be equal to the 1/3 y plus 6 because of those tick marks. Now, I can just write an equation like this and solve it using regular algebra. The only thing is it's tricky with those fractions, so I like to do a thing called clearing the fractions. Whatever number is on the bottom of those 2 fractions, if it's the same number, I can multiply by that number. And since both of the fractions have a 3 on the bottom, I'm going to multiply by 3. Now, what happens with the 2/3 is the 3's would cancel out and I'd be left with 2y. So you kind of distribute this, right? 3 times 3 is 9. 3 times 1/3, the 3's would cancel out and I would have 1y. And then 3 times 6 is 18. Now look at how much better that is without the fractions. So really I have 2y plus 9 equals y plus 18. I don't really need the 1 in front of there. But now I can subtract y. I get y plus 9 equals 18 minus 9, y equals 9. We also have to solve for x. I didn't leave myself much room here, so I'm going to have to squeeze it. But because the transversal on the right had congruent segments, that means the transversal on the left is also going to have congruent segments. So the 3x minus 4 will equal the 5/4 x plus 3. Those 2 will be congruent to each other. Now, again, there's a fraction. I don't like to work with fractions very much, and so I'm going to multiply by the denominator, which is 4. I'm going to multiply by the number on the bottom of the fraction. I'm going to distribute that to everything. So I'm going to wind up with 12x minus 16 equals, and now when I do 4 times 5/4, the 4 will cancel, so I'll just have 5x, and 4 times 3 is 12. That equation looks much nicer for solving. So minus your 5x. So we have 7x minus 16 equals 12. Add 16. Sorry, I'm kind of squeezing this in here. 7x equals 28. Divide by 7. X equals 4. All right, we're going to talk quickly about a few definitions that you should know. The first one is called a perpendicular bisector. A perpendicular bisector is a line, segment, or ray that intersects a segment at 90 degrees at its midpoint. A line, segment, or ray that intersects a segment at 90 degrees at its midpoint. Let's say I have a segment. Let's say I have segment AB, and I want to draw in its perpendicular bisector. Well, it's going to have to come down at a 90-degree angle, and it's going to have to cut AB in half. So the perpendicular bisector would be that blue vertical line. It's perpendicular to AB, and it bisects AB. Now, the perpendicular bisector theorem says that no matter what point I pick on that perpendicular bisector, like I could pick a point right here, it's going to be equidistant to the two endpoints of the segment. So the distance from there to B and from there to A would be the same. So let's jot down that theorem. If a point is on the perpendicular bisector of a segment. If a point is on the perpendicular bisector of a segment, then it is equidistant. Equidistant means equal distances from the endpoints of the segment. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And again, I'll just show you one more example on our picture up here. I can pick any point on that perpendicular bisector, like maybe this point up here, and the distance to B and the distance to A will be the same distance. All right, and then the last definition here is angle bisector. So imagine you have an angle. I'll just draw an angle over here. Maybe I'll call this A, B, and C. So we have angle ABC. Well, guess what an angle bisector does? An angle bisector is going to come and cut that angle in half. So in this case, ray BD could be the angle bisector of angle ABC. It will cut it in half. So let's talk about what the theorem says. Well, the angle bisector theorem says pick any point on that angle bisector. Like let's say I pick this point right here in yellow. The distance down to one side, side BC, and this is going to be the shortest distance, so it would be perpendicular, and the distance to the other side will be the same. So this distance and this distance would be the same. So the angle bisector theorem says this. If a point is on the angle bisector of an angle, if a point is on the angle bisector of an angle, then it is equidistant from the sides of the angle. If a point is on the angle bisector of an angle, then it is equidistant from the sides of the angle. I think it's just easiest if we go to the examples, so let's do that. Number 5, you can see that we have 19 degrees here and 19 degrees here. That means that ray RU bisected angle TRI. And that means this distance and this distance will be the same. So 2x plus 5 will equal the 7x. Solve it. 5 equals 5x. Divide by 5. 1 equals x. However, we are not quite done because if you look at the question, it says find IU. So we're going to take that 1 and we're going to plug it in right here. And we're going to say IU equals 7 times 1, which is 7. And there's no label here, so we do not need to label. Last question. So it says find WZ. Well, one of the things I notice is that line WX right here, this is a perpendicular bisector to ZY. See how it's perpendicular? It meets it at 90 degrees right here, and it cuts it in half. And so I can pick any point on that perpendicular bisector, like I'll pick W, and this distance should be the same. It should be they should be equidistant to the endpoints of segment YZ. So 4x minus 5 will equal the 2x plus 11. Minus your 2x. 2x minus 5 equals 11. Add your 5. 2x equals 16. X equals 8. Now it says find WZ, so you are going to have to plug that back in. So WZ is going to be 2 times 8 plus 11. So 16 plus 11, so what is that, 27? And I don't think there's a label, so we could just say WZ equals 27. Great, will you guys please try Unit 5, Practice 4. Have a great day.